let's just jump right in. We are absolutely swimming in data these days, right? It's coming from everywhere all the time. But here's the thing about raw data. It's kind of like crude oil. It's messy, it's unrefined, and honestly, you can't do much with it. The real value, the real magic, happens when you transform that raw stuff into something clean, reliable, and powerful. You know, when you turn it into digital gold. So that leads us to the big question for anyone working with data. How do you actually pull that off? How do you build a system that can handle this chaotic flood of information and step by step refine it into trustworthy insights that a business can actually bet on? Well, that's exactly the puzzle we're going to piece together in this explainer. And to do that, we're going to follow the entire journey of data from start to finish. We'll kick things off with the blueprint that gives our data some much-needed structure. Then we'll look at the automated assembly line that processes it, the engine that gives it power, the specific language we use to shape it, and finally, how to unlock those advanced insights that make this whole thing worthwhile. Okay, first things first, you gotta have a plan. You wouldn't try to build a house without a blueprint, and it's the same deal with data. You just can't build a reliable, high-quality data product without a solid architectural design. This is where we lay that all-important foundation for quality. And that blueprint has a name, the Medallion Architecture. Now, this isn't just some random Databricks idea. It's really become the industry standard for building a modern data lakehouse. It's a beautifully simple concept. You just organize your data into 3 distinct layers, or tiers, and with each layer, the data gets progressively better, cleaner, and more valuable. So here's how it works. Your data hops from one stage to the next. It all starts in the bronze layer. Think of this as your raw, untouched landing zone. It's a perfect historical archive. From there, it moves into the silver layer. This is where we do the heavy lifting, cleansing it, filtering it, and conforming it so it makes sense. And finally, it lands in the gold layer, where it's all aggregated and polished up into business-ready tables ready for your BI dashboards and analytics. Every single step adds more value and more trust. So, we have our blueprint. But a plan is pretty useless if you can't actually build the thing automatically and make it scale. This is where we need a smart assembly line. And in the world of Databricks, that assembly line is called Delta Live Tables. You know, before tools like Delta Live Tables, or DLT for short, building data pipelines was just a procedural nightmare. Seriously, you had to manually code every little step, juggle these complex orchestration tools, and you were always on edge about something breaking. DLT completely flips that around. Instead of telling it how to do everything step by step, you just declare what you want the final result to look like, and DLT figures out the how for you. And the benefits are just huge. DLT handles all the orchestration, managing all the dependencies and recovering from errors, so you can ditch a bunch of external tools. It processes data incrementally, which means it only looks at new or changed data. That saves a ton of time and money. Oh, and my favorite feature? You can build data quality rules, what we call expectations, right into the pipeline itself. So quality isn't some extra step at the end, it's a core automated part of the process from the get-go. Okay, so our automated assembly line is designed, but it needs an engine to make it go. In Databricks, that power comes from compute clusters. And believe me, choosing the right engine for the job is absolutely critical if you want to balance top-notch performance with a reasonable budget. And the logic is actually pretty straightforward. If you're doing interactive development, sure, you'll use an all-purpose cluster. But for our automated DLT pipelines, the smart move is a jobs cluster. Why? Because it spins up for one specific job and then shuts down when it's done. You literally only pay for what you use. And even better is going serverless, where Databricks handles all the underlying infrastructure and you get billed only for the actual processing time. It's fantastic. And we're not talking about small optimizations here. When you match the right kind of compute to your workload, like using a serverless DLT pipeline for your big transformations, the cost savings can be as high as 98%. Nope, that is not a typo. Making this one choice can completely change the economics of your data engineering work. All right, let's take stock. We've got our blueprint, we've got the assembly line, and we have the engine. Now we need the actual tools to get in there and shape the data. This is where the language of data comes in. DDL, or Data Definition Language, and DML, Data Manipulation Language. And inside of DML, there is one command that is, without a doubt, the data engineer's secret weapon: merge into. This one command lets you do something called an upsert. It intelligently looks at incoming data, finds records that already exist and updates them, and then inserts any records that are brand new.
It is incredibly efficient for common tasks like change data capture, and it just makes complex data synchronization so much simpler. And Merge is built on the rock-solid foundation of Delta Lake's other features. You get full ACID transactions, which means your operations either complete 100% or not at all. No more corrupted data. You can create auto-incrementing ID columns and set default values, just like in a classic data warehouse. It's this blend of features that really makes the Lakehouse architecture so powerful.
We are on the home stretch. Our data has been ingested, it's been cleansed, it's been structured. Now it's time for the final step, creating those complex aggregations for our gold tables and making absolutely sure everything meets our quality standards. And for this part of the job, we're going to turn to PySpark. So you might wonder, what makes PySpark so incredibly fast? Well, a big part of it is a concept called lazy evaluation. The best way to think about it is like a GPS. Instead of just starting to drive the second you get in the car, your GPS first looks at your entire route, all the transformations you want to do, and figures out the most optimized path before a single piece of data even moves. This is what lets it crunch through massive calculations so efficiently. And the primary tools for this final aggregation step are the group by and ag functions. I mean, these are the real workhorses. Data engineers use them to take that beautiful, clean data from the silver layer and roll it up into those valuable summaries that the business needs for the gold layer, things like total sales per quarter or average customer spend. But hey, building the pipeline is really only half the battle, right? You also have to keep an eye on it. And for that, the observe function is just a fantastic tool. It lets you define and track your own custom metrics, like how many null values you have or a count of invalid records, as the data is flowing through, and it does it all without slowing down performance. It's kind of like having a real-time quality control inspector right on your assembly line. So let's just recap that whole journey one last time. We started with the Medallion Architecture as our blueprint. We used Delta Live Tables as our automated engine. We powered it super efficiently with serverless and jobs clusters. We used powerful tools like DML and DDL to shape the data. And the end result, a reliable, business-ready data product that people can actually trust. You see how each one of these pieces just fits together perfectly to create this modern, robust, and really efficient system for turning that messy, raw data into something truly valuable. So I guess the only question left to ask is, now that you have the blueprint, what are you going to build?